Hey, welcome back. Engineering is about solving problems by moving them to a different domain. This is my approach to a 3D printed quick release. The reset is a compliant spring integrated into the base, simplifying the mechanism by making the structure do the work. The problem: plastic is great for geometry but fails under high pressure mating and long term mechanical load. Instead of fighting these limits, I decoupled the functions. The print defines the form, the hardware handles the stress. Even the actuator uses this logic. The bearing presses against the screw head to prevent the cam from digging into the slider's plastic. But the real rigidity comes from the 4-point interface. I moved the critical tolerances to a domain I can control. The cam drives the slider, but the stress path is entirely metallic. Zero flex because we aren't relying on plastic for the lock. This detent adds a tactical state. It's either locked or not. Stability through geometric constraint, not just friction. These countersunk head conical interfaces serve a dual purpose. They align the parts and pull the plates together with massive force. By forcing the plates to mate, we maximize surface friction. This turns two separate parts into a single rigid assembly. The result is a mechanism that behaves like a solid metal unit, achieved by strategically decomposing the problem. Don't just print a part, design a system that outsmarts the limitations of your tools and materials. Fast, repeatable, and reliable. Complexity solved through smart domain transfer. Thanks for watching, and I'll see you in the next one. Bye.